Good afternoon to all of you. So just for about 10 minutes, we will go for summary of the pre-yesterday's class. So here in the yesterday's class, we discussed about the generalized measurement system and also the dynamic characteristics of a measuring instrument. In this generalized measuring system, three stages are there. One is uh, input stage, that is a detector transducer stage. The second stage is intermediate stage. The third one is output stage. In the first stage, uh, we are having a sensor and transducer. Here the sensor detects the variable from the environment. Then the output of the sensor, it's a transducer, it receives the signal from that, and then it converts into the another form of the signal. It is convenient form. Then it is it is entered into the intermediate stage. In the intermediate stage, so what is here, a manipulator is there, transmitter is there, processor is there. So these three, in other words, this intermediate stage, we can also call it as a signal conditioning section. Signal conditioning section means here the output from the transducer is the input to the intermediate stage, right? Here the output from the transducer is nothing but a signal, electrical signal, or maybe the another form. So this form signal is conditioning in that particular intermediate stage. Here signal conditioning means the signal is making correct whatever the defects in the signal in that particular intermediate stage. The signal is making correct. That means the signal is conditioning. Conditioning means here making correct. The signal is making correct in that particular intermediate stage. So after that, lastly it goes to the output stage. In that output stage, what is happening here? Directly recording or monitoring or displaying. These are all the things in the output. That means directly we can go for reading the data or measuring the data, variable, physical variable. Right? Okay. And then next, in that dynamic characteristics, we discussed what we discussed. Anyone can post. Anyone can post in dynamic characteristics. So one person energy transfer to another. Okay, a single is not CRT. Transducer measuring lag. Measuring lag means some delay for measuring the physical value, some delay, and speed of response very good. Speed of response is when you give input, we can get the output very fast. That way, whatever the quantity, the speed of the measured quantity is very fastly. And fidelity, right? Fidelity means whatever the input will reproduce the same as that of the output. And dynamic error. So here dynamic error means I already told to you that uh, when the system is in on position, the reading is fluctuated. So we cannot get the correct reading. The stable is not there due to some disturbances. And measuring like over dynamic measurements, overshoot, right? Overshoot frequency response. Here overshoot means here what is the overshoot? Anybody? It's overshoot. Here overshoot. Anybody can tell? Okay, right, correct. It's overshoot. Overshoot. Overshoot can briefly go for just one sentence with 5 words. Does not right. Very good, Naveen. Number 30. lateral entity that does not come immediately. So overshoot, that means maybe trust, right? Here, whenever, for example, one meter, any meter, maybe speedometer, accelerometer, or vibrometer, or a voltmeter, whatever meter is there. Here the some experiment analysis is running. Here it is showing some 80 or 90. Whenever input is off, automatically it not come down fastly. So overshoot. That means it will take some time. Slowly it comes to the normal position. So overshoot. If you go for a graph in the overshoot, it goes to the zero to the some time and does not immediately come, right? The next, another frequency response. So within that frequency response only, here we can go for measure the uh, quantity, measure the quantity within a limited range of frequencies. If it exceeds that one, it does not work properly. That is the meaning of frequency response. That frequency matches, then only it works correctly. If it exceeds that limit range, then limit or range, then automatically we cannot get the output correct. That is called frequency response. So, okay, right. And the next today we are going to discussing right, well and good. We are going to discussing about the sources of error in measurement and calibration. So, yeah, what are the errors today? After completion of this particular class, you can learn about what are the types of the errors are there, okay, and in which way the sources of errors will occur, and calibration. We will discuss. uh, Mostly three errors are there, and three errors we will discuss one by one. And then calibration, also what are the sources to occur error in an instrument, right? Anybody can tell the errors. Last previous we discussed some errors, right? What are those errors? Static error, dynamic error. Static error and dynamic error. Already we discussed. So any errors are there? Anybody can post message. Any errors? Errors. Yeah. What is the meaning of the error? Wrong. Error means some mistake in the reading. Clearly is some mistake. How can you say that mistake? How can you say, of course, wrong, right? It's a wrong in the reading. How can you say that is a wrong? How can you say that is wrong? Now, this is very, very, you have to think. How can you say it is right by comparing with standards? Very good, Mr. Lavanya Reddy, right? Very good. All 320, right? Sunil, all are right. Deviation in measurement, standard, right? Always we have to compare with the true value, standard value. For example, if my body temperature is 120 degrees centigrade means, I will say it is wrong reading. I know my body health, right or wrong. Example I'm saying. So if the instrument I placed maybe the temperature measurement instrument, thermometer, I placed it in my mouth under the tongue. Then if it reads 110 degrees centigrade means, simply I will say that the instrument, simply I will tell that instrument is giving a wrong reading, wrong measurement it is. So once a wrong measurement means, then what we have to do? Wrong. We know that wrong to the true value. Example. So what we have to do? Next step. It's wrong. Output is not equal to the input. Okay. Deviation measurement, right? So what we have to do? What next step? What we have to do? If any instrument, it should be like that. Then we have to go for calibration. Here, see, calibration. Here, see, the calibration. See here, calibration. The instrument has to go for calibration. That means if there is a calibration means that whatever the reading should be almost all closer to the standard value or a true value. We have to go for calibration for that particular purpose only. Calibration. Here, calibration means I will tell you later. So, if the instrument is giving error, that means a wrong measured quantity, then you have to go for a calibration of that particular instrument. Once if the calibration process, we have to find out where the defect is going on, we have to make it correct, and then in such a way that again that instrument is working properly within the range correctly. We have to do like that is actually the calibration procedure. Make a right, very good. ఎవరు చెప్పారమ్మా ఇక్కడ నెంబర్ 312 lateral entry, you said 100% right. Making instrument accurate, right? Accurate means what the other sentence I said. What you have to calibrate such a way that the value should be closer to value. That means what is the meaning? Closer to the true value means accurate only. Closer to the true. What we discussed in the previous definitions, accuracy means it's close to the true value. The reading is close to the true value. So we have to be make calibrated in such a way that whatever the defects we have to find out, and then we have to make it in that particular instrument so that the reading should be close to the true value. Then the system is accurate. That's what the making instrument accurate. Very good, Nana. Very good. Number 312. You are in fundamental knowledge. So I am very happy. I am satisfied. Right. Number 312, lateral entry, Ravi Teja. You are right. Making instrument accurate to the standards. Correct sentence. Right. Right. Now we'll discuss, right? We'll discuss. One by sources of errors. We'll discuss one by one. Errors in measurement. Limiting errors. That is guarantee errors. Some errors will be occur guarantee, compulsory, maybe some manufacturing defect, and known errors. Some errors you know very well. No, you know that errors. Some errors should be there. That one, whatever the reading we are getting, we are going to go for plus or minus. Then we can get the correct. So that one, according to that, actually these are the limiting errors and known errors. In these two types only errors are there. Then in these errors, the classification, if you go for classification, three types of errors are there. Right. One is gross error, and another one is a systematic or cumulative error. Another one is random error or residual error or accidental error. And then next, another in this system or cumulative, instrumental environmental observational error. So in this one, this instrumental, it's environmental observational error is in systematic error. It is in systematic error. So now we'll discuss one by one. Gross error, what is a gross error, and what is systematic, and what is a random or residual accident. We'll discuss these three clearly. See here in this gross error. Gross error, human mistakes in reading. All of you see here. Human mistakes in reading, recording, and calculating measurement results. That means these gross errors are made by the human. Gross errors are accepted value. Accepted value. Of course, Maybe sometimes wrong it is. Lavanya Reddy, 345. Gross errors, of course. The value is accepted, but it is wrong. I will tell you. See here, in this, if you observe clearly, example, due to oversight, oversight means some a defect in I. Instead of 21.5 degrees centigrade, he will read 31.5. That means 3, for him it appears, uh, that means the 2 it appears it appears as a 3. That means due to oversight, instead of the 21.5 degrees centigrade is the correct answer, but he will read 31.5. Of course, here the measurement, that whatever here the parameter, what type of parameter is the physical variable temperature. Actually, it shows correct, but the human is making mistakes by taking wrong due to the eye defect. So that type of errors is called gross error. This is not the instrument problem. Instrument is giving reading correct. Now you got the point. Of course, she said that gross error is accepted value. Here I will tell you the difference. 45, 345, I will tell you the difference. The instrument giving reading is accepted, but the human taking the reading is wrong. This is the difference. That type of error is called a gross error. Gross error. The human is making mistakes in reading or as well as in calculating also. Sometimes the divisions may be 2, 3, or 4 like that. For example, least count. Already you know the vernier calipers, you did measure the diameter of so and so bolt or a nut. So in that the vernier, you go for accuracy, you get the accurate value. You go for vernier calipers, right, or screw gauge, micrometer. Then the least count, by counting the least count, if the calculation is wrong, means total the value is wrong. Of course, it is the reading is showing correct, but the human is making whatever the making mistakes. That type of one you can call as a cross errors. Here, the experimenter may grossly misread the scale. Sometimes misread the scale. It should be 5 on the 4, maybe 4. So like that, some that gross errors are the mistakes made by the human, not by the instrument. Instrument is giving true value, and that is also accepted value. Here, see in that another one, they may transpose the reading value while recording, like reading 25.8 and record as 28 point. See here this is a lot of difference. Here 25.8, while transferring recording, we are recording in such a way that 28.5 degrees centigrade sometimes. So one member is telling that 25.8 to me. I am somewhere some distance 1 meter or 2 meters. So by listening, due to the listening problem, I will return 28.5 degrees centigrade. These are all the problems made by the human, not by the instrument, right? So now you got the clear. Gross error is okay, right? Next we'll go for the next error. Systematic errors, right? Systematic errors. In systematic errors, there are systematic errors. We can also call it as cumulative error. Cumulative error. See here, in this in this systematic errors, 3 are there: instrumental error, environmental error, observational error. These 3 errors. In the instrumental error, to occur the instrumental error due to these 3 reasons. So one is due to inherent shortcomings in the instrument, due to misuse of the instruments. due to loading effects of the instruments. That means inherent shortcomings means the instrument uh, unexpectedly some disturbances, some vibration, some friction. Due to that, it will shows sometimes a wrong leading. Maybe a fluctuations takes place, more fluctuations. It leads to inherent shortcomings in the instrument. Inherent shortcomings in the instrument. We are talking about in the instrument. Inherent shortcomings means what are the shortcomings? Maybe friction, maybe vibration, maybe some other fluctuation in voltage. So example, these are the examples. It leads to what happens means the reading is not incorrect. This is the instrumental problem. This is instrumental problem. Whereas the gross error is instrument is working correctly. The human is making mistakes by taking reading or recording reading. Whereas in the case of the systematic errors, due to this inherent shortcomings, that means here the problem where occurs in the instrument only, due to the friction, due to the vibration, and due to the fluctuations in the voltage, maybe the pointer will not give the correct reading, maybe a wrong reading. That is, and due to misuse of the instrument, sometimes we can go for misuse of the instrument. That means whenever the instrument we are going to use, we have to use in a precautionary measures. We have to go for that. That means misuse. If you avoid that, if you do not go for precautionary measures, if you does not obey the precautionary measures, you exceed that one, then automatically we can use the that means misuse. We are misusing the instrument. And loading effects. What I said due to loading effects, that is nothing but the fluctuations in the voltage. The fluctuation, the loading effects of the instruments. Sometimes maybe the pointer breaks. These load effects will more, whatever that it is exceeds the range, then automatically even the pointer also will be break. It's damage. So the here these are all the instrumental. These are the three reasons main in the instrumental error. And in the next one is environmental error. These errors due to the conditions external to the measuring device. This may be effects of temperature, pressure, and humidity, dust, or for external static or magnetic. Yeah, these are the reasons. The instrument here, the instrument, right? Environmental means the instrument is here. It affects on some parameters surrounding that one. What are the parameters? Uh, the temperature, humidity. For example, in the largest industries, due to that environmental, maybe the instrument may work and may not work sometimes. Maybe if work means, then the reading is not correct. So these are called environmental humidity due to the humidity. For example, if you observe, take our wall clock watch. For example, in the summer season, here the watch will go somewhat slowly, maybe 5 minutes. Why? Because due to the summer season, here the whatever the needles will elongate, will elongate. Thereby, the rotation may be somewhat it goes for slow time, slow, slow. Time is very slow. That means 5 minutes slow. Whereas in the case of the winter season, here the pointer or the needle will contract, thereby somewhat maybe 2 or 3 minutes of fast going time. So these are the environmental. With the help of the with this environmental, due to the change in the temperature or maybe the change in the humidity, there will be change in the reading, some errors. That minor errors, not the big errors. And dust or external static or external magnetic field. Now it is clear. I think all of you understand, right? Next we will go for the next one. What is the next one? Observational error. Here in the observational errors here, the error observe. What is the meaning of the observation here? Observing. Who is observing? Human. Human is observing the reading. In that reading also, what we said in the gross error, the human making mistakes in taking reading in such a way that that is a calculation, reading oversight, these are all coming under gross error. But this is also, see, observational error means that is also by the human only. This is coming under systematic errors. I will tell you that is called parallax error, account of parallax error. Next slide, I will give the clear idea about this observational error by the human taking a measured measuring value. Right. I will go for the next. See here, observational errors. Here, when the human, see here, when the human eye is at here, this is the human eye that is here, then automatically it reads at this point. See here, all of you see here, reads at this point. And when the human eye is at this point, then here, see, the needle is at here. Here the reading is, see here, the needle is same, at same position. There is no deflection, it is in correct position. But when observed from here, it should be appear like this. But when observed from here, it appeared at this point. But when you observed it here, it appears at this point. See here, there is a variation. This is called the parallax error. So here, now here in my house, the power is cut. With the help of the UPS, it is running. So maybe 10 minutes or 10 minutes or 15 minutes, the class will be there. Automatically, it will be disconnected again. Okay. So all of you listen carefully, and I also this is the problem in my house here. That the power is cut off. Maybe now it is running with UPS. In 10 minutes and 15 minutes, maybe the UPS will work. And after that, disconnect. So till that, we will continue the class. If current comes, means we will continue up to 4:30. That's right. Next. So now all of you understand that observational error, right? Observational error means here in the reading, the needle is the same position, but by observing the human from the left side and the right side and from the middle side, automatically there will be small change in the reading, small change in the reading. And we will go for the next one. Next slide. Sources of errors. These are the sources of errors. Here, insufficient, see here, insufficient knowledge of process parameters and designing conditions, and poor design in the instrument, and change in process parameters, right? Manufacturing errors. Poor design is nothing but manufacturing errors, poor designing. And also for skilled persons, insufficient knowledge of process parameters and designing conditions. The next point is change in process here, change in process parameters, irregularities, upsets, disturbances, and poor maintenance. Here, the maintenance for a particular instrument is required. So, because the instruments already we said it's a very sensitive. So, for example, if you buy one instrument, if you do not use it for 3 months, 4 months means in the fifth month it will not work, because the instruments are electronic goods which are very sensitive. And errors caused by the people who operate the instrument or equipment. Certain design, some limitations will be there. So some limitations. So these are the sources of error. And anybody, any questions up to this? We'll go for the next one. And elimination or reduction of methods of these particular errors. Here, how can we go for elimination means we have to go for calibration. We have to recalibrate carefully every year or every 6 months. We have to calibrate the instrument such that whether the reading, whatever we are getting the value, that the value should be very closer to the true value. That means accurate, right? Accurate. So you have to, if there is a defect means we have to make it correct, or we have to go for maintenance of that particular instrument. The procedure of measurement must be, see here, must be carefully planned. Substitution methods or calibration against standards. We have to go for some standards. Against standards, we have to calibrate. Against standards, against the true values, reference values. We have to calibrate for that in such a way that. And the next correction factors should be applied after determining. We have to go for correct them. We have to apply the factors. Correction factors should be applied after determining the instrument. The next one, the residual error. See here, this residual error or random error, we can also call as random errors. This is the last one error. These errors are occurred due to unknown causes. That means we cannot expect unknown causes and are observed when the magnitude and the polarity of a measurement fluctuate inchangeable, random. That means we can say correctly fluctuate, maybe plus or minus, polarity changes, plus or minus. For example, some readings should be right. For example, in the take, for example, uh, in the weighing machine, it shows that minus 250, like that, minus 0.250. What we have to do, whatever the weighing, we have to go for example, 500 grams is 500 plus another 250 grams. We have to go for polarity changes plus 250. Then only we can get the correct weight. Am I right? Or accept this? So random errors means maybe sometimes fluctuates. Sometimes మీరు చూసే ఉంటారు చాలాసార్లు వెయింగ్ మిషన్స్ దగ్గర. So here in the weighing machine, it shows that
వెళ్ళిపోదామా ఫస్ట్ బ్రో? వెళ్ళిపోదామా?
రవి
నేనే
రవి
అరే అటెండెన్స్ చేసాడే లేదా?
లింక్ ద్వారా వస్తుందంట, కంగారు పడక్కర్లేదు, వాళ్ళకి వచ్చేది.
రవి ఎక్కడున్నారా?
ఏనా ఇంట్లో
చెప్పు.
మరి సారేర్రా సారు
బాత్రూమ్కి వెళ్ళి
ప్రశాంత్ ఏ సార్ లేరేంట్రా? సారేర్రా
ఎవర్రా కార్లు పెట్టారా?
Number 21.
తరుణ్ తరుణ్ కుమార్ తరుణ్ కుమార్.
Hello bro, silent కూడా.
రిక్షా దగ్గరికి వెళ్ళాలమ్మా.
విజయ్ గారు నమస్తే అండి.
రాజేష్ రాజేష్ నెంబర్ 5 రాజేష్
చెప్పరా
చెప్పమ్మా.
సారేర్రా
టాపర్
సారేర్రా రే
అంటే చెప్తున్నాను ఇక్కడ
ఏంట్రా?
పవర్ ఆఫ్ అయిపోయిందంట.
రాజేష్ టాపర్
భోగేష్ సార్ భోగేష్ సార్
సార్ మనోజ్ గారు
ఇప్పుడు వంశీ కుమ్మడి
నెంబర్ 24.
చందన్ చందన్
దగ్గర పవర్ పోయిందంటరా.
అవునా?
మరి
చందన్ చందన్
అంటే అదే సార్ ఇంట్లో
నేను ఏదనుకున్నా.
అరే భోగేష్,
మేక 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 రోల్ నెంబర్ 2
అరే మామ భోగేష్
చందన్ 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 చందన్
అరే,
చందన్
అరే, ఏంట్రా,
చందన్
వెళ్ళిపోతున్నాడు
చందన్ చందన్ చందన్
ఏంట్రా?
ఏర్రా ఎక్కడున్నారా? అరే రా. ఏం చేద్దారా?
చందన్ 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 పూరి ప్లేట్ పూరి
చూడండి.
అరే రికార్డింగ్ అవుతుందిరా అంతా. హలో
హలో, ఎవరన్నా సార్ ఫోన్ చేసి అడగండి రా. సిస్టమ్ ఆగిపోయిందంట. మనం అందరం క్లాస్ అయిపోవచ్చా లేదారా? అయిపోవచ్చులే.
బాబు చందన్ ఏంటి నీ అసలేంటి?
క్లాస్ అంతా రికార్డ్ అవుతుంది.
రికార్డ్ అయిపోతుంది.
వినో బ్రో వినో.
జూమ్ క్లాస్ రా. మాట్లాడమన్నా అడగమంటారు లేదా?
తొలిసారి ప్రేమించవే రెండోసారి.
ఏమంది కావాలరా? అడగమంటారా లేదా సార్ని ఫోన్ చేసి?
వద్దరా బాబు.
బ్రో నువ్వు వల్లకుండా ఉండు బ్రో. అది రికార్డ్ చేసేవాడు సంజయ్ రాజ్ కూడా రికార్డ్ చేస్తున్నాడు బ్రో.
సంజయ్ రాజ్ గాడా? సంజయ్ రాజ్ గారు ఆడిచ్చాడు.
సంజయ్ రాజ్ ఈజ్ హాస్ట్.
మనకి హోస్ట్ ఇంకా అడికి వెళ్తుంది ఏంట్రా? హోస్ట్ మన క్లాస్ లో
బాయ్స్ స్పెషల్.
హోస్ట్ పెద్దనేడు ఇక్కడికి వెళ్తుందా? మన క్లాస్
హలో నమస్తే.
హాయ్ ఫ్రెండ్స్. హలో
బాబు భోగేశ్వరరావు ఇది కాఫీ క్లాస్ కాదమ్మా.
కాఫీ వద్దా నీకు మానేస్తే ఇంకొక పంపుతాను చూడు ఏం పంపంటారా
అరే హలో హలో సార్కి ఫోన్ చేసి అడిగాను రా. సార్ దగ్గర పీసీలో కరెంట్ పోయిందంట, లీవ్ అయిపోమన్నారా.
బ్రో ప్రశాంత్
లీవ్
బ్రో
అయిపోమన్నారా సారు.
ప్రశాంత్ బ్రో ఓకే బ్రో.
లీవ్ అయిపోతే అయిపోంటారా మేము ఉంటాంరా మేము మాట్లాడుకుంటాం
అరే ఎతవా ఏదో ఒకటి చేసుకో.
హలో రే రే చిన్న అనౌన్స్మెంట్ చెప్తానేనండి
చెప్పు.
మైక్ టెస్టింగ్ 1 2 3 పాట పాడరా హలో చర్తో పాట పాడు హలో
అరే చందన్ చెప్పరా.
రే
చెప్పు.
స్పూన్ తో తీసుకొని చేతితో
హలో
తీసుకో
చందన్.
హలో
చెప్పు బ్రో.
క్లాస్ లీవ్ అయిపోవచ్చు అంటరా
బాబు మేము ఉంటాం బ్రో, మేము మాట్లాడుకుంటాం, మేము మాట్లాడుకోవాలి, కష్టం కాదు మాట్లాడుకోవాలి. నీకు వెళ్ళిపో నువ్వు వెళ్ళిపో.
హలో 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 వాయిస్ ఎందుకు వినిపించట్లేదు చందన్ అరే రమేష్
బాబు బొజ్జా జగదీష్ కుమార్ ఎవరమ్మా?
బొజ్జా జగదీష్ కుమారా ఆడు ఏ సెక్షన్
ఏ సెక్షన్ బొజ్జా జగదీష్ కుమార్? ఆర్ యు దేర్?
సారా ఫోన్ చేశాను సార్ లీవ్ అయిపోవచ్చా అంటే వచ్చమ్మా అన్నారు.
బాబు యువరాజ్ డాంకా.
నడిచండి వెళ్ళిపోదాం ఇంకా ఉందగా అంత కంగారే నీకైతే ఐఫోన్ ఇదేంటి రమేష్ అరే చందన్
సంజయ్ ముందు రికార్డింగ్ ఆపండి మీరు పోస్ట్ ఇద్దరు.
బాబు చందన్ యాడ్ చేసావు అనుకో రికార్డింగ్ ఆపుతో ఆపు.
లేరా